So it's working. Okay, so
Yeah.
thanks for having me, because it's a huge pleasure for me to be here also and to talk in this community event. I like Global Azure, and I like that we can all share our experience between different MVP in different countries. So I'm very happy to be here. And as you said, I will talk about network today, and specifically about virtual WAN, and what we can do with virtual WAN in terms of hub and spoke, and regarding that, what it brings to the table regarding the routing. Because if you work with hub and spoke, you know that sometimes it's a little pain to manage the routing. So what we'll do, first, a little review of the hub and spoke topology, and why virtual WAN is nice, to say the least. Then we'll have a little bit of hands-on basic virtual hub topology. So we'll start small, just a virtual WAN hub, and then how it bring to the table a virtual, well, an hub and spoke topology, way simplified. And then we'll do a little bit more tricky stuff, because we will want to add a secure hub, and have a look at more routing in it, depending on our scenario. If you have only one hub and one route, or more than one route and more than just one kind of spoke that you want to connect, and we'll have some experimentation, and some failure maybe, and some well, some configuration anyway. And then I conclude with a little summary, and talk about some other feature that I did not talk about today, that I would like to talk another time, but then I would need a whole day, so that's not an issue. Okay, let's get started. So just to get started, a review of what is hub and spoke, and why we like virtual WAN. So, you probably know that in Azure, the recommended network topology is hub and spoke, which consists of, as you can see on the screen, a virtual network which is called a hub, and other virtual networks which are called spokes. The virtual network hub is centralized, is a central network. It's used to centralize some services, to also centralize the connectivity. So if, for instance, you have an hybrid network, you would like to avoid having what I call the spaghetti network, meaning that you connect all your VPN and different network to all of the different spokes. It's unmanageable. So you have an hub and spoke topology in which you have only one network which is connected to your other non-Azure network. Okay, that's the main aim of the hub and spoke topology, because you probably know that, but express route is expensive, so you cannot have that many express routes. So that's why you have one express route connected to one virtual network, the hub, and then all the spoke can access to the other networks through this hub. Okay, another use case for the hub and spoke, as you can see, centralizing some firewalling, specifically for east-west traffic. If you want to have traffic between the hub on the left and no, the spoke on the left and the spoke on the right, you need something to secure the flows, but also to route the flows, and that's where you need something like an Azure firewall. So in this schema, you can see that I've written Azure firewall subnet because I chose to put an Azure firewall. You don't have to do it. You can do whatever network virtual appliance that works for you in a virtual hub, no, in a virtual network hub, but you need to install it yourself, or to install an Azure firewall, and then you can configure your workload. Okay. There one important point in the hub and spoke with only virtual network is that, as you can see also on each of the on the spoke, you need to manage the routing configuration in all of the virtual network spoke. More than that, in all of the subnets, because, well, a user-defined route is associated to a subnet. So it means that if you want to tell to the machine on the left that it should go to the machine on the right by going through the firewall, then you need to tell it inside a route on the subnet that contain the virtual machine. And then you have also other issue. If, for instance, you did not want to have another virtual machine in the same network to be routed to the firewall to go somewhere over there, then you would not be able to do it that easily. You would have to configure some specific routing. Anyway, so as you can see, you need to be in a distributed mode of routing configuration, which is in the long run a pain to manage. So what brings virtual WAN for the hub and spoke topology? First, the virtual WAN allows us to deploy a virtual, one or more than one virtual hub, which are managed virtual network, emphasis on the manage, that lives inside the virtual WAN. Because those virtual hubs are managed, we don't do anything in it except specifying the network range. Sorry. We just specify the network range, and then by default, it comes with a default route table. And when you connect the spoke, the routing is centrally managed on the virtual hub. Instead of having to manage the route into each spoke, once you connect the spoke to the virtual hub, the route from the virtual hub is propagated so that the spokes can get access to each other with some routing. So you don't manage anymore distributed routing, it is centralized. And in this scenario, at least, this is very easy to do. What is also interesting is that in the past, with the let's say the classic peering, you need to configure peering on both network. In this case, you don't. You just manage the peering, which is not a peering, but displayed as a network connection from the virtual WAN, the virtual hub. In fact, this is still a network peering, but kind of a managed peering, so that's changed a little bit. So that's one way of seeing it. If you look at the scenario where you want to have more than one virtual hub, because for instance you have let's say one region which is Europe and one region which is US, you may want to have more than one hub to connect each spoke to the regional hub. If you are in classic hub and spoke configuration, you need to add those spokes, those hubs, and to also pair them together. So we can still do that. If you are in a virtual WAN configuration, you have one virtual WAN, and you deploy as many virtual hubs as you want, and they will be automatically connected together. Okay. If you want to have a look at a virtual WAN, we'll do just that. We can find in the portal when we look at our virtual WAN once it's deployed, information on the topology, the existing topology. So you will see that this topology is a little bit different than the one I show you in the portal, because I prepared for the next step of the demo. And you will see also that we can have a look at the virtual hub, and also what the routing configuration and the network that are configured, that are connected to it. So let's switch on the cluster on the Azure portal to have a look at that. I will zoom a little bit because this is a little small. Okay, so as you can see, I have a dashboard prepared, and here I have a virtual WAN. Okay, so in this virtual WAN, the first thing that we get when we click on it is the global geography of our virtual WAN. As you can see here, we have the world map, and we have one icon here representing the only virtual hub that I created. If I created more than one, I would have additional virtual hub that would be visible across all the map. Okay. If I click on topology, I will see what I showed you earlier on the slide, except that this time it will be a little bit different. Oh, I need to change the color. Usually I'm always in dark mode, but it does not work fine with the topology. So let's change that. And I will accept for once to be in non-dark mode. Okay. Also, as you can see, we have the topology. We can see the virtual WAN. You can see the virtual hub here with a different icon, but I will explain that later. This is because I added the firewall in the picture, and you can see all the connected network on the spoke, on the hub. Okay, so that's the view that you get of your topology. You can have you can download this topology. You can view some detailed metrics if you want to have a look at that, depending on what you have configured in your environment with, because this is a workbook, with your log analytic workspace. Okay, let's switch back to that, and let's switch back to the dark mode because it's blinding me. Appearance dark. Okay, so switching back. If I click on the hub here, you can see I have my sole virtual hub, and you can also see that I have some virtual network connection. So that's what I was saying. If I want to manage the peering to my virtual hub, I don't manage that from the virtual network. I manage that from the virtual hub. I need to wait that it loads, and then in the meantime, I will also prepare another window for which hopefully I will be able to do something. Okay, so while it's working, I will have a look at my virtual network to show you the peering from the network point of view. Where are my network? Spoke demo 1. Okay. And I will switch to the peering side. Let me zoom that a little bit. You can see here that I have indeed a virtual remote peering, but if we click on it, we'll see that, well, we cannot see that much things. This is something that is configured with the virtual WAN, the virtual hub from the virtual WAN. And you can see that if I want to manage that, I need to authenticate because this is not considered a resource in my directory because this is a managed resource. So that's funny because indeed this is in my tenant because I can see it over there. Okay, I could add a network connection from the portal and select my virtual hub and then another virtual network. Let's say, for instance, I could take the network from my Cilium cluster, and then I could configure it. I won't just to show you the step. Then I would create the peering from the portal. So again, as I said, a centralized mean to manage the hub and spoke configuration. Okay. Okay, switching back. What do I have here? So I've showed you the configuration. I showed you the current topology and how we can access the peering configuration. What if I want to see what's happening between my virtual machine? So let's switch back again on my portal and have a look. So as you can see here, I have more than one network connected to my hub, and in my virtual network, if I click on this one, so we need to do it that way. If I click on this one, you can see in the connected device, I should have some stuff. Yes, I do have some virtual machine. So this one is connected to subnet 1, this one is connected to subnet 2. Let's have a look again on my dashboard to find the virtual machine so that I can check some configuration and have a look at how it's working. Before doing that, if I look at my virtual network configuration, the virtual network, this one, in its routing configuration, is configured by default. So if I look at the routing configuration, it uses a default route table, and it propagates the route to the virtual network connection, propagate the route to the default route table. I will come to that in detail. Let's switch while we are here to the virtual hub, sorry, and have a look at the route table. It always takes some time to load because, well, there is a lot of things inside that. But once it's loaded, you can have a look at that. You should see in a few seconds the different route tables that are associated to my virtual hub. And then we'll have a look at the default one because this is the one that we are interested in for now. So by default, when you create your virtual WAN and your virtual hub, you will get a default route table for each virtual hub. Okay, and this default route table is what allows you to configure your routing. If I look at the association, you can see that we have two virtual networks associated, and you can see here that those are the virtual network 11 and 31, so that's 1 and 3 finally, but I have default in my naming. And you can also see some other configuration that we will try to explain. If I look at the propagation, this is very important. You can see that we have two networks that are configured. Also, this is not the one parameter that I wanted to show you. But anyway, the network configuration is done so that the route for the virtual network is propagated. So let's have a look at that. I told you that I had some virtual machine. So what I can have a look at is one of my virtual machine in my spoke. And I will look also at another one in the third spoke because they are all those two virtual machines are one of the different spoke. Let's have a look at the check. I should look at the networking settings, and I want to have a look at the routing configuration. So this is my network interface. And this is where I will find the effective route. Doing that, I will also, because it will take sometimes, I will first have a look at the result of the routing configuration with a very helpful tool, which is the network watcher that you probably know. So the network watcher is over there. And I want to see if I can find the path from my virtual machine that I just look at to the second virtual machine that I want to look at, which is the 31. So let's have a look at that. So this is not this one that I want to check. So I want to check this resource group, virtual machine VM1. And I want to find the path for another virtual machine that hopefully I can find here. Virtual machine, I will find this one. If I go to the network configuration, look at the network setting, I should find the private IP address. Perfect. So going back to that, doing this and this, we should find that we have a route which is expected. We want to have a look at what is this route and how it got there, and that's what we will get by doing by looking at the network interface over there. I can look this one, and I can look this one over there. Okay, so here you can see I got that. Next up, virtual hub with an IP address which is managed by the virtual hub. You can see route table ID gateway route. Okay, so that's not the default route that you have on your virtual network. That's something that was propagated by the connection. If I look at the route, you can see it here. You can see that I have the default system route from my network, my virtual network. You can also see that I have additional route, which are the 172.21.104/24. If I'm correct, it should be the network of my network 11, right? Yes, that's it. Because by default, I don't have that route on my spoke, but it was propagated when I created the connection. Okay, so we have something similar when we do a direct peering, but this is not a direct peering here. Remember, if we have a look back at our slide, which are there, we are in an hub and spoke. So I have that, and the route from this one to this one was automatically propagated, as I've written on the schema, that way. Okay, so that's something that was brought to the table because the virtual WAN is helping us to manage the routing, and that's why you get that, and you can see that we have the root source from virtual network gateway, which is the gateway inside the inside the virtual WAN. Sorry. Okay, fine. So I do have a root now. I can see there is also some difference here. I could have a look at what it is. I will have a look at that later if you want. Now going back to that, I can see that I have the next hop. I can see that I have the route propagated. So that means that I can find my traffic. Can I look at that? Maybe I can try another thing. If I look at the EP flow verify, if I want to check virtual machine 1 accessing to virtual machine, so I will check that. I will look at the remote port. I don't care. This is the remote port. Oh, remote port. I will look 22. Is it that way? Direction inbound. Local port. This is 22. Sorry, I need to do it that way. I always have an hesitation on that one. And remote IP address, I will take the IP of my virtual machine earlier, which was over there. And if I was not wrong in my estimation, I should be able to verify that the flows are effective, but this one is not verifying the routing, it's verifying the effectiveness of the network security group. You can see that we have allowed access because I have the virtual network, the default network security group rule that are helping me. But because I have a virtual WAN, if unless I had something in between, once I peer my spoke to my virtual WAN, to my virtual hub, then they will be able to find the route as I've shown you. And unless you have some more restrictive rules on your NHG, with the all of VNet inbound, which is the default route, they will gain access to get all of them together. Okay, that's interesting and something that we need to take care of if we think about security, because we don't want to have default allowed traffic on all of our hub and spoke topology. Okay, but if you are just in this configuration, that's what you get. Okay, going back to my slide. Moving on. So this is what I've shown you. You can see the effective routes that I've showed you earlier. And you can see the result of the network watcher for the next hop estimation. Okay, so if I summarize in this very simple implementation, and then we will do a little bit more technical stuff with the firewall in between. With the virtual hub in virtual WAN, I just need to configure the virtual hub network range at the creation, and then I manage centrally in a central point the connection of the spokes. I don't need to manage the connectivity between the spoke because there is a router included that propagates the route. And as you have seen, unless I have some specific network security rules, the traffic is also allowed. So this is a very plug and play hub and spoke topology that is very easy. Also, if I want to have another hub in another region, it will automatically be created and associated to the virtual WAN, and so I will find a route with the default route because it will propagate everything together. In comparison, when I have an hub and spoke with virtual network, I need to configure everything in my hub. I also need to configure the peering from both sides in the hub and in the spoke, so not centrally. And I need to add a new hub if I want to have a new hub, and to manage the connectivity with something in the hub so that they can find the route. And then I also need to have a user-defined route. Okay, so it's really less easy to have a working virtual working hub and spoke topology without virtual WAN. Okay, but what if you want to do some secure stuff? Because we want to do secure stuff, right? So we need to add some additional resources. So to add some additional resources, we need to consider what we would add. In our case, we will add a firewall, because an Azure firewall, because it's easy, and this is one of the projects that I know. But you can add some additional network appliance as long as they are available in the virtual WAN, which is not the case for all the security partners that you might think about, as opposite to what you have in the classic virtual hub, because in a classic virtual hub, you just rely on the marketplace, and you have a lot of products available to do some security in your hub and spoke topology. If you choose a virtual WAN with virtual hub, you're limited to what you bring to the table. Either it's an Azure firewall, which kind of does the job. Either you find one that is available. So if I'm correct, you have something about available from Palo Alto in a kind of a SaaS model. You have something available from also FortiGate, I think, and maybe Checkpoint, but I'm not sure. Apart from that, if you want to enforce the firewall, you need to modify the routing, and that's why I talk about GPS to the routing in hub and spoke in virtual WAN, because you need to understand the routing configuration to be able to use your firewall. Okay, and then you need obviously a firewall policy to manage the rule, but we won't spend too much time on that. We want to focus on the routing today. All right. Okay. So if I want to use my firewall, I need to change the routing. So here you can see some extract of some Terraform configuration, but you don't have to do it through Terraform. This is just one sample so that I can illustrate that before moving on my portal. I need to create a new route. So that's what I did here, a new hub route table. As you can see, if you are attentive, it's already available in my virtual hub, because I don't have the time to provision it during the session. And then I need to add specific routes on this route table so that I can say that for a specific address, I want to go to the firewall. So that's what I did here. So I added two different routes, one that I called internet route, and one that I called a private CIDR route. The first one takes everything, so 000/0, and it goes to the next hop, which is a resource ID, and I specify the resource ID, which is my firewall. Okay. Then I associate that to the route table ID, which is this one that I just created. And I do the same for the private range from the RFC 1918, which are the range that are displayed here. Once I've done that, it means that all the spoke connected to the hub with this route will go to the firewall, meaning that they have a route to talk together, but they will come to the firewall, and if the firewall doesn't allow it, and by default it doesn't allow it, it won't work. So you need to manage the firewall rules apart from that. We'll have a brief look at that. Then you need to change the network connection. Again, here it is an extract of a Terraform configuration, but I will show you the result on the portal. You need to change the routing configuration of your configuration so that the peering, the routing, the network connection is associated with the new route table that you created, and you also propagate differently the route. Earlier, when I had my configuration with the default route, I propagated the range for my network connection, so the range for my spoke, to the route table, and that's why I had the route to the spoke between the spoke together. Okay, the route was one route that propagated everything, so it's easy, it's working fine. No, I don't want to do that, because if I still propagate the route, I won't go to the firewall, so it won't work. Okay, because the route that is propagated at the connection is the route specifying only the range from the spoke that is connected. So this is a shorter route than the route that I define here. So if I do that, this route, this generic route, and I also propagate the route to the new route table, then I still won't use my firewall. So I need to be very thorough on that. So that's why I need to configure it specifically. So let's switch back again to my portal. Okay, so now going back over there, you can see that I have this specific route table that I created. If you look at that, you can see that I have some association. You have 3 networks specified, the network 4, network 2, and network 5. And you can see also, if we look at the network connection again, can I do that from here? Let's go back here. Let's go back to the network connection. And we'll see that there are some little difference that I just explained you, but I want to illustrate my purpose here. And it's taking some time to display. In the meantime, I will prepare my network watcher to watch the flow from virtual machine inside the spoke connected to the new route table. So let's take this one. Let's take, as I said, there was the network 2, if I'm correct, and I will try to go to the network 5. Is my virtual WAN displayed? Okay, so you can see I have my virtual network connection here, and this one, if I'm correct, is changed. So look at this one. As you can see, this one is associated to the route table RT lab 001 and propagate to none, yes, while earlier this one was associated to default and propagate to none, no. So that's the difference that I showed you on the slide earlier. That means that I propagate in the default route, I propagate the route for the spokes to the route table, while when I want to use the firewall, I need to say no, I don't want to propagate the route to the route table, I propagate that to another route table that exists in the configuration, which is the non-route table. So this non-route table is a specific artifact that exists solely for this purpose to allow us to go through the firewall. And you can see here, we will have, once it's displayed, 3 routes, the default one, the one that I created, and the non-route table that is specifically used so that we don't propagate the route from the spoke to the route table that we use in the connection. And then, because we have additional route on our route table going to the firewall, we can force the traffic to the firewall and then allow the traffic. So you can see here, we have the non-route table, no associated connection, but propagated connection 3. And you can see this is the same number because this one has three connection for the 3 spoke that I connected to it, but I did not propagate the connection. I propagate the connection to this one route. So this is a little bit fuzzy when you don't know it, but once you get it, it's quite clear. If you want to use the firewall, you need a specific route, and you need to not propagate the route for from the connection to this route table, but to the non-route table, and then you will specify on this route table the route so that you go to the firewall. Okay, and you can see it here. I have internet to firewall, which goes to the firewall. I have private CRGI to the firewall, which goes to the firewall. This is what I showed you earlier in the slide. If I go now to my configuration, so do I have a virtual machine? I took the network 4 and 2, and if I'm correct, the 4 is also concerned in here. Let's just verify that. Virtual network connection. And then I go to network watcher. And if I check the next hop this time, because I prepared the connection, we should see something different. And we will have a look at what it is. And we should see that it's the firewall that is in between. 10, 100, 254, 132. Can I verify that? I wish I can, so I'll do it. Let's check again in my portal. I should have one firewall available. Firewall, one over there. And if I check its configuration, if I'm correct, yes, that's it. So as you can see, this one, those virtual machines are talking together through the firewall. So we need to have the firewall allowing the flows. To check that, we can just have a look very shortly, as I said, on the firewall manager, because the firewall in the virtual hub are managed through the firewall manager. And you can go into the Azure firewall policy, and you should see here the firewall-based policy. Do we have some rules? I forgot which one it is. Associated to it should be this one. And if I go to the rule collection, I should see a bunch of rule collection. Yes. So you can see I have rule collection spoke 41, which allows a few stuff. The only interesting thing that I want to show you, I don't want to into the detail of the load traffic, but the interesting thing here is that we can specify either the IP address or an IP group, which is a specific Azure object for the Azure firewall. I can show you that. You should leverage that if you need to manage rules in your Azure firewall. When you create a network, you can also associate afterward an IP group that will act as kind of the same way as an application security group, except it's for an Azure firewall, and you associate IP and not virtual machine. If I look to the resource group part, I should see in this one, I should see the IP group, and the IP group is just something that I created like that. This is just a label. This one is not associated to a rule, but if I check, for instance, this one, this is no, not this one. Can I get the? See, it should be this one. No. There is one for the network and one for the spokes. So this is this one, not this one. I want to check the one for this one. And you can see here, if I'm correct, that it is associated to rules, and you can have a track of that in here. Okay, going back to the slide a little bit over there. So I need to change the routing. Once it's done, I need to allow the traffic, and then I have my traffic working. So this is a summary of what I explained you with the demonstration, but you can get that in the slide. If you need to allow the traffic, you need to change your network connection. Remember, you need to configure the network connection with the route that will use the firewall, and you need to not propagate the network connection route to this route, but to the non-route table, so that it's not propagated, and so you can use your firewall. Okay. There's one other thing that I want to show you. I still have a few minutes. There is an option that is called Internet Security Enable. If you look at that earlier, look at here. When I create my virtual hub connection, I have an option which is called Internet Security Enable. The aim of this feature is to allow us to either use the Azure firewall as an egress gateway or not. Okay, so here, if I have routes to internet, if I have the internet security disabled, as you can see, the next hop for 88888, which is Google, as you probably know, will be internet, next hop internet with the default system route. If you have internet security enabled on your network connection, then the next hop will be the virtual network gateway, and the IP address will be, as you can see here, my firewall. Okay, right. So that means that I can use the virtual WAN and virtual hub to also secure and control my egress gateway. One thing to be attentive to, first, in the portal, this is not called internet security enabled. This is called propagate default route. So that's kind of very disappointing and very confusing. If you want to activate the security for your spoke so that it does not go on the internet without going through the firewall, this is this property over there. Okay, edit virtual network connection and then specify enable. Okay. Another point then, if you need to expose something on internet in the spoke and you enable internet security, then it doesn't work because you route egress traffic to the firewall. So even if you have public IP directly in your spoke with a load balancer or something, and you allow it on the allow traffic on the NSG, it won't work because the return traffic will be forced through the firewall, and the firewall will drop that because first, it's not allowed. Second, it's asymmetric traffic. So as a good firewall, it will drop the traffic. So be very careful about that. Expose our public virtual network. You don't enable internet security because you need to be able to go back outside. Not expose workload, you can enable internet security and you will be sure that the traffic is redirected to the firewall. Okay, that's a very important point, and it's kind of complicated, the routing. So I have 2 minutes left. One last thing before concluding. You may have some scenario when you have more than one kind of spoke. This is explained in the documentation in Azure in the scenario isolate virtual network custom, and that's what I try to display here. So imagine in our case that we have public spokes and private spokes. Okay, the private spoke, as I said earlier, are internet security enabled, because we don't want to allow them to be accessible from the internet. And they are behind the firewall, so they are using a custom route that is associated to the firewall, and that will force all the traffic to the firewall. Okay, so for those spoke, it's easy. The route is the custom route that we specified, and we say that from here to go there, we have the route associated on the route table that say that we need to go to the firewall. Okay, same here, so we need to go to the firewall. Okay, but as you've seen earlier, I specified all the RFC 1918 private IP address, which are also address used over there. Okay, so meaning that if I want to go from here to here, what happened? I want to go here, then I will follow my routes, which will tell me go to the firewall, and the firewall, he has no idea how to address traffic over there, because those networks are not connected to the same route, so we are not able to address it. Okay, well, it's not that, it's more than we can go to the firewall, but then those one cannot answer back. Those guys also, they are connected on a different route, which has no way of knowing that those spoke are addressable after we go to the firewall. So for that, we need to configure an additional configuration that is explained here, if I'm correct. Yes, that's it. We need to specify on the route table used by those one, we need to specify a route to go to the firewall. So that's why I showed you on with an extract from the portal here. So you specify an additional route to say, okay, to find the route to spoke 2 when you are in the public spoke, because spoke 2 is a private spoke, you need to go to the firewall. And so you specify, you call that specifically like that, route to spoke 2. You specify the address prefix, which is the range for the spoke 2, and then you say you go to the firewall. And then you need also to allow traffic, but that's how it's working. Okay, if you want to do that through Terraform, you can do it that way. That's a good way to do it, because then you know well, anyway, you need to automate that, because you need to classify your spoke so that they can be able to spoke together. Okay, so if you expose something into the internet, into the public spoke, then the backend of this public spoke need to speak to something inside the private spoke. You need to do that. Okay, so this is again explained in the scenario isolate VNet custom, except that in the scenario isolate VNet custom, they do not speak that much about Azure Firewall. So that's why I found that important, because I had this issue and it's not trivial to do. Okay, and I think that's all. Okay, so if I have to summarize, if we just speak about Hub and Spoke with Virtual WAN, the Hub and Spoke Classic is made easier by the Virtual WAN, because everything is automatically created. You don't manage anything in the virtual hub. There is some router that will propagate the route for you, and you can even configure custom routing if you want. So virtual WAN is well, in my opinion, a good point to go for the evolution of the hub and spoke. You have centralized management for the routing, as I said earlier, which is very interesting. And you also have the way to transform your hub into a secure hub. And in this case, you need to leverage some custom routing. Okay. Once you go to the secure hub, you need to understand a little bit more of the routing strategy that you need to use, because you can either do it as I showed you earlier, or use other means to do that. So that's the other point that we could have a look at, but we don't have the time, obviously. If you want to not use different route table, you can use something that is called routing intent, which is a little bit more network oriented than Azure oriented, and that allow us to use a firewall and use only one route. Okay, I'm not sure it should replace the strategy with multiple route table if you want to have different kind of spoke, which should be associated together. I'm not sure yet, but I did not test it yet, the routing intent. Secondly, I talked about it earlier into the basic hub and spoke with virtual WAN. If you want to add additional hub, it's easy. You can do it, and you will have automatically a connection for the spoke, for the hub together. And unless you do some custom routing, everything is routed together. Then, once you add some custom routing with different firewalls, so obviously, if you want to do that, you would have more than one firewall in each of your hub. Then you need to be very careful about how you route that. You will need to do what I showed you earlier with the routing configuration on each of the routes, so that you can specify for one group of spoke that if they need to talk to another group of spoke which is behind another firewall, then they need to have the route configured on their route table to find their PAL. Okay, so again, some more routing configuration that need to be explored if you want to attain the hub and spoke topology that maybe become more complex. And that's all for me.
Great. Thank you very much, David, for your presentation. There was many information about routing, so this topic isn't simple, like we know, because networking Azure is really complex.
Yeah, there is a lot of things in virtual WAN, and it changed a lot. So it's very important to follow up and to find the good strategy. The product did change. The good news is that there are more partners that are coming into it, so that in the near future you will be able to choose whatever appliance that you want to use if you don't want to use firewall, because this is often the case. But anyway, it's mandatory that we understand the routing configuration to manage a complex scenario. Simple scenario, as you can see, it's automated, so it's okay. Complex scenario with more firewall and more security, not so easy. Not so easy.
We haven't any questions on the chat. I cannot see it, but I have one.
Yes, please.
It's one like a tricky question, not fully related of the routing, but what do you think about migration from standard hub and spoke network to vWAN? Do you see any benefits for preparing migration like that?
Okay, so first thing, migrating to that will depend. Well, it depends what you have. In a very mature and let's say customized hub and spoke, classic hub and spoke, you don't necessarily need to migrate, right? Because you already make it work. So okay, the advantage I see is the elimination of the user-defined routes, which, to be honest, I really don't like, because you need to configure if you want to propagate some route from your express route or not, if you want to address that on your subnet or not. And anyway, if you are in a distributed model, there's a chance that your people are contributor on their own spokes, so they can do whatever they want, and you have no clue if they want to modify the UDR. So if you don't want to have that, Virtual WAN is a good way to go, because you will centralize the routing, and then when they will call you and say, oh, it doesn't work anymore, you will say, yes, but it should not have been working before, so that's okay. So that's one good point. Then in terms of migration, you need to plan that accordingly, obviously. But if you have either a simple virtual WAN, virtual hub without firewall, or one virtual WAN, virtual hub with a firewall, so it's simple routing scenario, it's kind of easy to prepare. You prepare your virtual WAN, virtual hub, and then you break the peering and rebuild it. And it's working fine. I mean, at first, you could even connect the hub to the virtual WAN, so that you would have routing for that, and then you migrate progressively all the spoke together. It's not very long, and then you have it. It's working fine. The idea of doing it step by step is that there's a chance that you will miss some routing, not routing, but some firewall configuration, because depending on your network appliance, it's not managed automatically the same way that you manage the infrastructure. So you need to have all the people managing that, recreating the rules. So if you're lucky and you're using Azure Firewall, you can get your Azure Firewall rules through the same automation process. If you're not, you need to rely on all the projects that are living around the firewalling, and that's your main issue. Always the firewall configuration. One alternative would be to allow all at the beginning, but you don't want to do that, because then you cannot close it anyway.
Okay, that's a good point. Thank you, David, again for this presentation. Michał, do you have any question?
Yeah, if I can, of course. So I have a
yes,
question about the secure hubs. So because when you start implementing the virtual WAN with the secure hubs, with the Azure Firewall, we had some kind of issue about traffic between the secure hubs. So once the hubs was configured in virtual WAN, it's working correct. But once we convert them to the secure hubs, the hubs stop spoking each other. So this issue is like some kind of mistake of the configuration, or this is like normal behavior of secure hub?
No, it depends on your routing configuration. If you have more than one hub, you're right. If you add a secure hub, because you needed to add a new custom route, then you change the default routing behavior. So because you have not one route anymore, but more than one, then the hub together may not find each other, and that's why you need to specify the route together. So this is tricky, and to be honest, this is kind of new, because from not so long ago, when you look at the documentation, you could have only one secure hub and the other hub were not secure, and so well, it was not working as you would have expected it to do. So hopefully it has changed, but to be honest, I have not managed that many times more than one virtual hub. I'm trying to do it for one client, so it will be the surprise, as a matter of fact. But yes, it can be tricky, so you need to verify that you find the route between your hub, and moreover,
Okay.
not specifically between your hub, but between your spoke connected to your different hub. So this is the trick that I showed you at the end, except that you will specify the firewall in each hub to be the target of the spoke for the route. So some fine tuning in the routing.
Okay, cool. Thank you.
You're welcome.